Hello students. Today we'll be learning about quantum mechanical model of atom, its important features. As you have learned earlier, the quantum mechanics deals with the dual nature of matter, and the Schrodinger equation is the basic equation required for quantum mechanics, and it states that h cap psi is equal to E psi, where h cap is known as the Hamiltonian operator, which is a mathematical operator which operates on the wave function psi, and E is the energy of the electron. So h cap psi is equal to E psi has a solution, that is psi, which is called the wave function. As such, the wave function doesn't have any physical significance. Why it is important is because we are concerned with the value of psi square. Psi square is probability density, and probability density helps in understanding the region around the nucleus where there is maximum probability of finding the electron. We shall see the important features of quantum mechanical model. First point, the energy of the electron in atoms are having certain fixed values or discrete values, and so you say that the energy of the electrons in the atoms is quantized. Second point, the existence of the quantized energy levels is due to the direct consequence of wave properties of electrons, and they are nothing but the actual solutions of Schrodinger equation. Another thing is exact position and velocity of an electron in an atom cannot be determined simultaneously. This was stated by the scientist named Heisenberg. So, the path of an electron around the nucleus can never be predicted. Then, the wave function psi of an electron represents an atomic orbital. Now, you find that the wave function is nothing but the solution of the Schrodinger equation. We have several solutions for Schrodinger equation, and so we get lot of wave functions for the electron. The wave function for an electron gives the information about the electron. All informations about the electron are extracted from the wave function. Now, only if you know the value of wave function can we find out the value of the probability of finding an electron around the nucleus, and that is proportional to mod of psi square. So this gives an idea about the region around the nucleus where there is the chance of finding the electron, and that was called as orbital. And you find that the maximum capacity of every orbital is 2. That means only 2 electrons can be accommodated. Orbitals are three-dimensional region around the nucleus where there is a probability or chance of finding an electron. And you find that in order to explain the probability density, that is mod psi square, one has to know the informations or the identification number of the electrons, and we have 4 different identification numbers for the electron, and they are called as quantum numbers. There are 4 different types of quantum numbers which helps to understand the exact behavior of an electron in an orbital. The first one is known as the principal quantum number, which gives an idea about the energy and the size of the orbital. Second one is known as Azimuthal quantum number or subsidiary quantum number, or otherwise known as orbital angular momentum quantum number. and that is denoted by the letter L. So this gives the three-dimensional shape of the orbital. And then we have the next orbital with the next quantum number, which is known as the magnetic quantum number, which helps to identify the orientation of the electrons in the different orbitals. And the last one is explaining about the spin with which the electrons are moving about. Spin quantum number helps to understand the spin of the electron, whether it is spinning clockwise or anti-clockwise. So there are four different quantum numbers. First quantum number deals with the energy of the orbital, and that is given by the letter N. Principal quantum number designated by the letter N, and it can take values starting from 1, 2, 3, etc. up to N, where this denotes K shell, L shell, M shell, N shell, and so on. The second one is known as azimuthal quantum number, otherwise known as orbital angular momentum quantum number or subsidiary quantum number, which is designated the letter L, and L will have values starting from 0, 1, 2, 3, etc. up to n minus 1. Total of n values will be there, and that helps to understand the shape of the orbitals. The next one is known as magnetic quantum number, which is dependent on the azimuthal quantum number, and it is written by the letter ML, which designates the value starting from negative L to positive L through 0. That means, suppose if L value is 1, we have the ML value to be negative 1, 0, plus 1. Hope it is clear. So ML can have 3 different values when L value is 1. Coming to the last type of quantum number, which denotes the spinning of the electrons, and that is known as the spin quantum number, which is designated the letter MS. MS can have only 2 values. If it is having a clockwise spin, it is known as plus half, and if it is having anti-clockwise spin, it is called negative half. With the help of these 4 quantum numbers, one is able to exactly find out where the electron is placed in the different orbitals. One more thing, if it is the azimuthal quantum number that is considered, azimuthal quantum number is given by the letter L. L can take values starting from 0, 1, 2, 3, etc. And so you find that L value, if it is 0, it denotes the s orbital. L value is 1, we say that it is belonging to the subshell or the orbital, which is called P, and when it is L is equal to 2, we say it belongs to D orbital or D subshell, and if L is equal to 3, it belongs to F subshell, and so on. So the next one will be L is equal to 4. L is equal to 4 denotes it is in the G subshell or G orbital. So commonly you find that in order to explain the configuration of the different elements starting from 1 to 118, we just require S orbital, P orbital, D orbital, and F orbital. According to the quantum mechanical model, we say that the orbits or the shells are again subdivided into orbitals, which are region around the nucleus where there is a chance of finding the electron.